Today we're going to talk about extrema on an interval. So extrema are maximums and minimums. Okay, so there's multiple different kinds too. We'll talk about those. Here's the definition. Let f be defined on an interval I containing the point C. Then f of C is the minimum of f on I when f of C is less than f of x for all x's in I, which basically means this. If you were to graph this, you had something like this. Okay, and here's here's your interval from here to here, and C is somewhere in here. F of C would be a minimum, so we'd have a minimum right about here. If f of C is less than f of x for all f of x's. Okay, so you can see that that's a minimum. All right, and then if you look at a maximum, f of C is a maximum of f on I when f of C is greater than. So it's just, the opposite of it, or here we've got it. This would be a maximum right there. Okay. The minimum and maximum of a function on an interval are the extreme values, or extrema, of the function on the interval. The minimum and maximum of a function on an interval are also called the absolute minimum and absolute maximum. So this would be an absolute maximum right here because it never gets bigger than that. But you can have what are called relative maxes and mins. So if I have something like this, all right, this does not have a absolute maximum, but it does have a relative maximum right there. It also doesn't have a relative minimum, or it has a relative minimum. It doesn't have a absolute minimum. Extreme at the endpoints are called endpoint extrema. Okay. So the extreme value theorem, if f is continuous on a closed interval AB, then f has both a minimum and a maximum on the interval. So if you look here, this thing has a absolute minimum right there. And since it's a closed interval, it has an absolute maximum. This one here has a absolute minimum, but it does not have a maximum at all because this is an open interval. This thing is not defined at 2. It gets bigger and bigger as it gets closer to 2, but since it doesn't ever reach 2, it's undefined there. It does not have a maximum there. And same thing over here. Now, if this was closed, it would have a relative maximum over here. This one doesn't have a minimum, but it does have a maximum because it ends. The graph at the left has a relative maximum at the point 0, 0. So if you look here, there's the relative maximum. It has a relative minimum at the point 2, -4. It does not have a max or a min, an absolute max or min. All right, definition of relative extrema. If there is an open interval containing C on which f of C is a maximum, then f of C is called a relative maximum of f, or you can say that f has a relative maximum at the point C, f of C. And it's the same thing. If there is an open interval containing C on which f of C is a minimum, then f of C is called a relative minimum of f, or you can say that f has a relative minimum at the point C, f of C. Find the value of the derivative at each of the relative extremum for each graph. So this function right here is 9 times x squared minus 3 over x cubed. We're going to have to use the quotient rule on this one to find f prime of x. So that's going to be x cubed times 9. And then that's going to be 2x. Because the derivative of this is going to be 2x right there. Minus 3x squared times 9 times x squared minus 3 all over x to the 6th. That's just the quotient rule. And then we can distribute this in here. We get 18x to the 4th And if we combine this is 27x squared, and distribute it in here, we get 27x to the fourth. Let's distribute, minus. So this is all negative, so we'll take all this times that, and then a negative times a negative is a positive, and that'd be 27x squared, that'd be 81x squared, all over x to the sixth. And we can combine like terms. This is negative 9x to the fourth plus 81x squared over x to the sixth. And I can cancel out an x squared here, so this would be negative 9x squared plus 81 over x to the fourth. And it might just be easier to factor out a negative 9 and leave x squared minus 9 in there over x to the fourth. All right, that's nice and clean. Okay, so there's the derivative. Now, so let's find the value of the derivative at each relative extremum. So the extreme is at 3, 2, so we're going to go ahead and plug in 3 for x here. So then f prime of 3 would be 9 times 3 squared minus 9 over 3 to the fourth power. This is going to be 0, so this whole thing is going to be 0 over 81, which is just 0. Okay, let's look at the next one. Make some room here. Okay, f of x is the absolute value of x. So this is not differentiable here at 0. So we're going to have to look at this as the limit as x goes to 0 from the positive side of absolute value of x over x. And that's going to come out to be that doesn't exist. Well, the limit is always going to be 1 on this side, because it's going to be a positive divided by itself. So that's going to be 1, and then the limit as x goes to 0 from the negative side of absolute value of x over x, that's going to be negative 1. So this thing, it does not have a limit, and so we can't take a derivative of this thing. All right, let's move on to the next one. F of x is sine x. All right, so if we take the derivative of this thing, f prime of x, derivative of sine is cosine. And we want to go ahead and plug in 3 pi over 2. So f prime of 3 pi over 2 is cosine 3 pi over 2. And that comes out to be 0. Okay. Definition of a critical number. Let f be defined at the point C. If f prime of C is 0, or if f is not differentiable at C, then C is a critical number. All right, so you're going to look for asymptotes, you're going to look for endpoints, you're going to look for places where the derivative is 0. And those are going to be critical numbers. Okay, relative extrema occur only at critical numbers. If f has a relative minimum or maximum at f of c, then c is a critical number of f. So we're going to use these extrema we're going to use the fact that it's not differentiable, or the derivative is 0 to find critical numbers, to find maximums and minimums. So here we go. Find the critical numbers. This is what you want to do to find extrema on a closed interval. You want to find the critical numbers of f on the interval AB. You want to evaluate f at each critical number in AB. You want to evaluate f at each endpoint of A and B. And the least of these values is the minimum, and the greatest of them is the maximum. So let's just find one for an example here. So find the extrema of f of x is 3x to the fourth power minus 4x to the third power on the interval -1, 2. So what we're going to do is we're going to find the derivative. F prime of x is going to be 12x to the third power minus 12x to the second power. Okay, there's nowhere where this isn't defined because it's a polynomial. Okay, so we want to find out when is this thing equal to 0. So we're going to go ahead and set it equal to 0. And we can take this whole thing and divide it by 12. So we get x cubed minus x squared is still 0. And obviously, x, let's see, we can factor out an x squared. And now this tells me that since this times this equals 0, either this is 0 or this is 0, so x is 0 or x is 1. All right, if I plug either one of those into here, 0 minus 0 is 0, and 12 minus 12 is 0. So this thing has 2 critical points, but it also has critical points at the endpoints. Excuse me, -1 and 2. You need to check all those. So what we're going to do is we're going to find, we're going to have critical points also at x equals -1 and x equals 2. This is all my critical points right here. Now what we're going to do is we're going to go back and we're going to plug those into f of x and find out which one's the biggest one and which one's the smallest one. So f of -1 is going to be, if I plug -1 here and here, that's going to be +1 times 3. That's going to be 3 minus, if I plug in a -1 here, that's going to be -1, so that's going to be -4. So it's going to be 3 plus 4, which is 7. F of 0 is going to be 0. That one's pretty obvious. F of 1 is going to be 3 minus 4, which is -1. And f of 2, that's going to be 16 times 3 is 48, minus 2 cubed is 8, times -4 is -32, so this is going to be 16. Okay, so here's my values at the critical points. This tells me that this is my maximum right here, and this is my minimum right here. So I have a minimum at the point 1, -1, and I have a maximum at the point 2, 16. Okay, find the extrema of f of x equals 2x minus 3 times x to the 2/3 power on the interval -1, 3. Okay, so let's first find f prime of x. That's going to be 2 minus, let's see, 2/3 times 3 is 2, x to the -1/3. So there's my derivative. I'm also going to rewrite it like this, 2 minus 2 over the cube root of x. All right, so I'll set this equal to 0. See when this thing's equal to 0. So that would be when 2 is equal to 2 over the cube root of x. That would be when 2 times the cube root of x equals 2, or the cube root of x equals 1. So x is going to be 1. Now, that's the only time that this is going to equal 0. However, we're going to have an issue if we plug 0 into this thing. So x equals 0 is also a critical point because I can't divide by 0. And then we've got the endpoints, -1. Uh-oh. -1 and 3 are the endpoints. So there's my critical points right there. All right, now we will go ahead and plug those critical points into the original equation. So we'll find f of -1, f of 0, f of 1, f of 3. So if I plug in -1, I'm going to get -2 minus, let's see, -1, the cube root of that is -1, squared is +1, times -3 is -3. So this is -5. If I plug in 0, I'm going to get 0. If I plug in 1, I'm going to get 2 minus 3, which is -1. And if I plug in 3, I'm going to get 6 minus 3 cube root of 3 squared. All right, let's get out a calculator. Figure out what the value of that is. So 6 minus 3 times the cube root of 9. This is like -0.2403. Okay, so I have a minimum right here, and I've got a maximum right here. So my min is at -1, -5, and my max is at 0, 0. And we'll double check that, and that is correct. Okay. Example 4, find the extrema of f of x equals 2 sine x minus cosine 2x on the interval 0, 2 pi. All right, so first of all, let's find the derivative. So f prime of x is going to be 2 cosine x minus, the derivative of cosine is negative sine, so that's going to make that positive, and then by the chain rule, I'm going to have a 2 sine 2x. Okay, so let's see. We can set that equal to 0. We can divide by 2, so I get cosine x plus sine 2x is 0. And then, let's see. Oh, yeah, I can simplify this. Sine 2x, if you remember from last year, is 2 sine x cosine x. That'll make this easier to solve. And now I can factor out a cosine. 1 plus 2 sine x. Okay, so now I find out when is cosine equal to 0? On 0 to 2 pi, well, it's equal to 0 at 0. So x is 0. I'm sorry, cosine is not equal. That's sine. Cosine is going to be pi over 2 and 3 pi over 2. Then 1 plus 2 sine x, we got to figure out when that's equal to 0. So 1 plus 2 sine x equals 0. 2 sine x is negative 1. Sine x is equal to negative 1/2. So there, x is going to be 5 pi over 4, and I'm sorry, 7 pi over 6 and 11 pi over 6. Now, we also have endpoints of 0 and 2 pi. So I have 6 critical points. These are my 6 critical points right here. So I'm going to have to find f of all of them. So f of 0, f of pi over 2, f of 7 pi over 6, f of 3 pi over 2, f of 11 pi over 6, and f of 2 pi. All right, so let's see, I'm sorry, if I plug 0 in here, I get 0 minus cosine of 0, which is going to be 1. So this is going to be negative 1. Then I put in pi over 2, so 2 times sine of pi over 2, that's going to be 2. Minus, if I put in pi over 2, this becomes cosine of pi. So cosine of pi is negative 1, so that's minus cosine of 1, which is going to be 3. F of 7 pi over 6, so sine of 7 pi over 6 is negative 1/2 times 2 is negative 1. Minus, let's see, 7 pi over 6 times 2 would be 14 pi over 6. That's going to be 14 pi over 6 is going to be 7 pi over 3, which is going to be equal to pi over 3. Okay, so cosine of pi over 3 is going to be 1/2. So this is going to be negative 3/2 here. 3 pi over 2. Sine of 3 pi over 2 is negative 1, so this is negative 2. And then that would be cosine of 3 pi. So that's going to be negative 1. So that's going to be negative 1. And then 11 pi over 6, the sine of 11 pi over 6 is negative 1/2 times 2 is also negative 1. It'll be 22 pi over 6. Let's see, if I reduce 22 pi over 6, that's 11 pi over 3. And if I use the fact that it's periodic and take out 6 pi, that's 5 pi over 3. Okay, so cosine of 5 pi over 3 is going to be 1/2. This is minus 1/2, so this is negative 3/2. And then 2 pi, so that would be make this 0. That'd be cosine of 4 pi. So that'd be 0 minus 1 would be negative 1. Okay. How'd we do? We got all of those correct. So this is my maximum. And my minimum, there's a there's a minimum, there's a couple of them though. So there's one here and one here. So I have two relative minimums on this one. Okay, so I have a max at pi over 2, 3. And I have mins at 7 pi over 6, negative 3/2, and at 11 pi over 6, negative 3/2. That was hard mostly because you had trig functions you had to plug in. Okay, there you go. Lesson 3.1. Take a look at those problems, and I'll see you next time.